Alrighty, last part of lesson 8.5. We're going to talk about a shape called a kite. So what in the world is a kite? Well, let me draw an example and then we'll come back to that definition. Kite looks like that. Yeah, it looks like a kite. Alright, so what's important about it, okay? This side and this side need to be congruent. This side and this side need to be congruent. But you can't have all four equal sides, okay? So, let's go to our definition. A quadrilateral with two sets of consecutive congruent sides. But, and you could kind of say this two different ways here. You could say, but not all four sides are congruent. Or you could say something like, but no parallel sides. I'm going to go with, but not all four sides congruent. Okay? Let me give you another example. Almost rhombus looking, but not quite, and kind of go in the other direction. Okay, so these are congruent, and then these are congruent, but different than those two. So it could kind of be turned either way, basically. And this one's more typical of what you'd think of when you think of kite, like literally the kite you fly in the sky. And this one's a little more rhombus looking, but these are slightly longer than these two over here. Okay, so let's get into our sides, angles, diagonals, and other boxes. Okay, so sides. Let's look at that right here. Let's go to our list again. Opposite sides are parallel. No, a kite is not going to have any parallel sides. Okay, that's one of the ways you could define it, is it does not have any parallel sides. Okay, opposite sides are congruent. Now if you look at the back of the picture, it's not the opposite sides that are congruent like this. It's the consecutive sides. Okay, so you're not going to have any opposite congruent sides. All sides are congruent? No, that was part of the definition. It's not allowed to have all sides congruent. Consecutive sides are congruent? Yes. Is it 4 sets or is it 2 sets? Okay, well, there's one set right there at the top. There's another set at the bottom. Do we have a set here on the right side? No. What about over here on the left side? No. So it's only 2 sets. So D2 by definition. Okay. That's it for sides. All right, let's look at angles. Okay, so that's our next box here. All right, angles. Opposite angles are congruent. 2 sets or 1 set. All right, let's draw this out. Which, hopefully by now you've figured out that means we're either going to show that it's obviously not true, or we're going to prove that it is true. Okay, so let's draw a kite. Something like this. This is congruent. This is congruent. Now I'm going to draw one diagonal right through the middle here. I'm not going to draw the other one. This diagonal, let's use letters A, B, C, and D. I don't know if all this is fitting on the camera. Nope. Alright, so let me zoom out just a little bit. Okay, AC is congruent to itself by the reflexive property. So this triangle over here on the left is congruent to this triangle over here on the right by side, side, side. Okay, which means angle D is congruent to angle B by CP, CTC. Corresponding parts of congruent triangles are congruent. Now, let me draw that same exact kite. As I can get it to look almost the same exact. And I'm going to draw the other diagonal instead. A, B, C, D. Remember, by definition of a kite, those are congruent and these are congruent. If I draw this diagonal, well, that's congruent to itself. Do I have congruent triangles now? No. I don't have side, side, side because that doesn't match with that. They're different. Okay, so I don't have this angle congruent to that angle. Alright? So I do have one set of opposite congruent angles this way, but I don't have a set of opposite congruent angles that way. So I only have one set of opposite congruent angles. So looking at our thing here, opposite angles are congruent. 2 sets? No. 1 set? Yes. So A1 for angles. Okay, so we're going to put that right here, A1. And, sorry about that, that is a theorem in our book. Okay, so the theorem is theorem 8.19. All right. Let me zoom in a tiny bit here. There we go. Okay, theorem 8.19. And that theorem says that if a quadrilateral is a kite, then it has one set of opposite congruent angles, exactly one set. It cannot have two. Okay, let's look at other things for angles. Consecutive angles are supplementary. All right, keep in mind that if we have consecutive supplementary angles, that's the consecutive interior angle converse theorem would give us parallel lines. On a kite, we don't have any parallel lines. All right, so we're not going to have any consecutive supplementary angles. Okay, what about all angles are congruent? No, we already showed you how in this picture, okay, this angle up here is not going to be congruent to this angle down here. All right, so we do not have all angles congruent. And then finally, consecutive angles are congruent. Okay, well, if we look at a kite, I'll just go back to these pictures. Is it possible that maybe these two angles are congruent? Yeah, it's possible, okay, but it's definitely not required. Let's take a look at how that might work, okay? Let's say that this angle right here is 100. Okay, well, when you do opposite angles, this one set here is congruent, so that'd be 100. Could this also be 100? Yeah. 100, 100, 100 is 300. We know that all four angles in any quadrilateral adds to equal 360. So we could get that to happen, but it doesn't have to happen, okay? These two have to be congruent. Really, this and this, it doesn't matter as long as all four angles add to equal 360. So the only thing that's true is A1. All right, let's go to diagonals now. Okay, so right here, diagonals. All right, diagonals bisect each other. Okay, now maybe I should redo this so that it says both diagonals versus just one diagonal, because we're going to make some slight modifications. So let's go back to a picture of a kite, and let's draw this out here. Okay, so I'm going to call this WXYZ. All right, now if we draw both diagonals, I'll call this point here V, right here in the middle. Okay, now, by definition of a kite, we have this side right here, congruent to this side, and this side congruent to this side. Okay, let's see, what else do we know? Let's actually look back at this picture real quick. Remember how I proved these triangles are congruent? This is going to come into play in a little bit with diagonals again. But if these triangles are congruent, this angle up here would have to be congruent to this angle right here by CP/CTC, right? We can kind of turn it that way so you can see the whole thing. Remember, the triangles were congruent by side, side, side. These angles are congruent by CP/CTC. Well, these angles would also be congruent by CP/CTC. And the same thing would happen down here. This angle would be congruent to this angle by CP/CTC. So let's take that idea and let's use it right here. So that was this angle right here, congruent to this angle right here. Okay. Now WV is congruent to itself. I'm going to put 3 marks. Now if we only look at the top part of this triangle, or this kite, where we have 2 triangles, okay? Just look at that top part. Okay, this triangle right here and this triangle right here, WZV and WXV, we have side, angle, side, matching up with side, angle, side. So these triangles are congruent by side, angle, side. Now what does that tell us about these 2 angles right here? Well, once we have congruent triangles, we can use CP/CTC again. So this angle right here is congruent to that angle right there. The other thing though we know is we have a nice straight line here at the diagonal. And we know that a linear pair has to be supplementary from the linear pair postulate. Supplementary means they add to equal 180. So what are the only possible angles that can add to equal 180 and also be congruent? Remember, congruent by CP/CTC. Okay, so congruent, maybe it's like 80 and 80. Okay, but that doesn't add to equal 180. Well, what about adding to equal 180 like 80 and 100? Okay, but that's not congruent. So the only thing that's going to work for congruent and supplementary is 90 and 90. And if we have 90, we have a right angle, and if we have right angle, we have perpendicular. So what does that tell us about the diagonals? They are perpendicular to each other. Okay, but that's not really what we were wondering. We were wondering, it's going to be important later on, but we were wondering if the diagonals bisect each other. Okay, let's look at this again. We had the congruent triangles, right? Well, what about ZV and VX? Are they corresponding parts? Yeah, they are. Okay, so I'm going to put 4 marks on here. 1, 2, 3, 4. And 1, 2, 3, 4. So those are congruent by CPCTC. So this diagonal right here is being cut in half by this one. Now, does that mean that WV is congruent to VY? No. Right? This triangle here is not congruent to this triangle here. So this diagonal is being bisected, but not this one. Okay, so let's look at our diagonals. Okay, so it says diagonals bisect each other. Well, that's kind of true in a kite. Like I said, maybe I should rephrase this so it says both diagonals or just one diagonal. But what we're gonna do is we're gonna put A1. We haven't really numbered A on any of our other diagonals. Diagonals A. We just put A everywhere. Here we're gonna just put A1 to show that it's only one diagonal that's being bisected. Now that is not a theorem anywhere in your book. Okay, so this is just kind of extra. Okay, but we just proved that it works. One of the diagonals is bisected. Okay, let's look at what else we talk about here. Diagonals are congruent to each other. I think we could pretty easily look at that picture and you would understand that this does not have to be equal to this. Or in this picture here, obviously, this diagonal is definitely a whole lot longer than this one right here. Okay, so that's not going to be true. Okay, well, what's next? Diagonals are perpendicular to each other. Okay, we just proved that. I remember back at this picture here, we talked about how these angles were both supplementary and congruent at the same time, which means they had to be 90 and 90, so that's perpendicular. So definitely the diagonals are perpendicular to each other. That's letter C. So we're going to fill in letter C right here. And that is theorem 8.18 in our book. If a quadrilateral is a kite, then its diagonals are perpendicular. Now that one doesn't work backwards. You can't say that if the diagonals are perpendicular, then it's a kite, because remember a rhombus had perpendicular diagonals, and a square had perpendicular diagonals. So just because it has perpendicular diagonals doesn't tell me for sure whether it's a kite or not. But if it is a kite, then it definitely does have to have perpendicular diagonals. And that's going to be important as we move down into our other box, if you remember what's going on down there. But let's take a look at the last thing for diagonals. Diagonals bisect opposite angles, 2 sets or 1 set. Well, we already showed you that. This diagonal, as it runs through here, remember, CPCTC, those angles are congruent. Okay, and these angles are congruent. So this and this is 1 set. Okay, so the question is, well, what about if I run it that way? Let's look at that picture. Do I have any good reason to think this angle right here is congruent to this angle over here? And I'm going to put 2 marks because no, we don't have a good reason. These are not incongruent triangles, so we can't use CPCTC. This triangle here is not congruent to this triangle here. They have different marks on the sides. Okay, so these angles are not congruent. Okay, so this diagonal does not bisect the angles, but this diagonal does. Okay, so we have the diagonals bisecting 1 set of opposite angles. So we're going to write D1. Okay, D1 right down here, okay, in the diagonal box, D1. Now this again is not something that's in your book, it's just extra information. Now here's the main thing you need to understand, so I'm going to draw this out for you. When you're dealing with a kite, there is one diagonal that does all of the bisecting. Okay, so here's my kite, I've got my congruent sides. Now if I draw this diagonal in here, going this way, you'll notice that this triangle up here does not match this triangle down here. It's, if you think about flipping, like reflecting across that diagonal, okay? Kind of like right here with this one. If I reflect triangle ADB down here, it doesn't match. It's kind of easier to see it if I go sideways. So if I take triangle ADB and I flip it over this line, it doesn't match up. This one mark doesn't match over here. If I do it here though, if I take this and I flip it down this way, ADC, it does match. Okay, so that one diagonal does all the bisecting. Okay, so it's not this one, it's this one. Okay, so this diagonal right here, it bisects the whole kite into 2 congruent triangles, which means these angles are congruent, these angles are congruent, these angles are congruent, and it bisects the other diagonal as well. Okay, so this one diagonal bisects everything. It bisects the whole shape, it bisects the other diagonal, it bisects the angles that it touches. This diagonal, when I draw it this way, This diagonal doesn't bisect anything. It doesn't bisect the other diagonal. It doesn't bisect the angles. It doesn't bisect the whole shape into two congruent triangles. It bisects nothing. So this one bisects everything. This one bisects nothing. Okay, you need to make sure you understand that. Okay, so diagonals. D1. One diagonal bisects a set of opposite angles. The other one does not. Okay, what about other? Okay, area. Base times height? No. Base and height are not perpendicular to each other. Length times width? No. The length and width are not perpendicular to each other. Diagonal 1 times diagonal 2 over 2. Are the diagonals perpendicular to each other? Yes. Then this is the formula we're going to use. That's letter C. Okay, remember the things we multiply together to find area need to be perpendicular to each other. Okay, letter D. Sides squared? No, the sides aren't necessarily perpendicular to each other. Do we have two bases? No, remember bases are parallel to each other. Kite doesn't have anything that's parallel. Mix between a rectangle and a rhombus? No. Mid-segment is parallel to the bases? No, we don't have bases. So there we go. That finishes off our sheet. Okay, this whole sheet, if I zoom all the way out, you should have all of this information filled out. Okay. If you don't have something that looks like this filled out completely, right, then you need to either go back and watch the videos, you need to talk to some friends and figure out what you're missing. But this whole sheet needs to be filled out, and you've got to start working on memorizing all this stuff. Okay, so going back to just the kite, okay, a quick review and then we're done with this lesson. A kite is a quadrilateral. It has two sets of consecutive congruent sides, but not all four sides are congruent, or you can say but no parallel sides. So we got these congruent sides here and another set of congruent sides here, and they're different lengths. Congruent sides here and here, here and here, but they're different lengths. D2, what was that? Consecutive congruent sides, two sets, and that's part of the definition. For angles, we have one set of opposite congruent angles. Diagonals, one diagonal is being bisected. The diagonals are perpendicular to each other, and one diagonal bisects a set of angles. When we say a set of angles, it's going to bisect both angles that it kind of goes through. And the formula for area is diagonal 1 times diagonal 2 divided by 2. Last thing for a kite. I'm going to give you an example of finding area of a kite. Okay, so let's say we get something like this. And now we know the diagonals are perpendicular to each other. Okay, I'm going to turn it this way so it fits in the camera better. Alright, so the diagonals are perpendicular to each other. Alright, so if I want to find the area, I'm going to do diagonal 1 times diagonal 2 divided by 2. Now, you may not get, all the information that you're looking for. Let's say we have something like this. Let's say this is 9, and let's say that this is 15. Okay, and then let's say that this is, I don't know, we'll just make something up here like 18. Okay, well, this diagonal is the one that's being bisected by the other one. So if this is 9, then this down here also has to be 9. So that diagonal from here all the way down to here is 18 units long. Okay, what I don't know though is I don't know this diagonal. Okay, so how can I figure that out? Well, I need to know this distance right here. Think, how do we find missing distances? This is a right triangle. Okay, so we're going to use Pythagorean Theorem. I'll just call it x for right now. So 9 squared plus x squared equals 15 squared. Okay, hopefully that makes sense because the 9 and the x are the legs, the 15 is the hypotenuse, so we have to have the hypotenuse over here. 81 plus x squared equals 225. Subtract that 81. X squared equals 144. Square root on both sides. X equals 12. Okay, so let's fill that back in here. X equals 12. Okay, now how long is this whole length then? Don't multiply the 18 and the 12 together. Add the 18 and the 12. So that's going to give me 30 here. So how do I find area of a kite? Diagonal 1, which was 30, times diagonal 2, which was 18. 30 times 18, don't forget, divide by 2. Well, 30 times 18 is 540, divided by 2. 540 divided by 2 is 270. Once again, whatever label we're using, is it feet, inches, whatever. Okay, so diagonal 1 times diagonal 2, but keep in mind that since you have right angles here, you do have right triangles, and you can use the Pythagorean Theorem as needed. Okay, that's it for kites. We've got one lesson left in Chapter 8, and that's lesson 8.6. And that's kind of a accumulation, kind of a culmination of the whole chapter, and talking about how these different shapes relate to each other. And then we're going to just do one separate thing that just deals specifically with area, because the book didn't really do a whole lot with area in the homework, so you're going to have a worksheet for that as well as we finish up this chapter.